Of course, we had to have our own infographic, and I'm pleased to say that in the United Kingdom, under United Kingdom RAP, we've now seen 35,000 kilometres of road star rated according to the iRAP star rating protocol, and more than 50,000 kilometres of roads are crash risk mapped every year. We've now got well over 1,300 users of the iRAP system called VIDA. It means life in Spanish. And we're helping the road safety initiatives in the United Kingdom, both through our work with DFT's Safer Roads Fund, where we've seen now nearly 200 million of investment on nearly 100 routes across the English A roads that are not on the major road network. And we're helping to shape plans for RIS3 through our partnership with National Highways. We also train and we have a few accredited individuals in the United Kingdom. So the iRAP process starts with a road survey. So historically we went out with these asset management vehicles with 3 forward-facing geo-referenced GIS cameras on the front and 1 pointing rearward and so on. Actually, technology has moved on so much that now we can stick a GoPro or a Garmin on a windscreen and off we go. And we can collect really good quality videos of the road network that are geo-referenced and can be inputted into road coding software. So then we move on to the road coding from the videos. This is done primarily manually at the moment, although there are many initiatives going on to smooth this process and make it easier through machine learning and AI and so on. In the coding process, which is currently undertaken by teams of iRAP accredited coding coders, is done in accordance with a very tightly specified coding manual that you can find on the iRAP website. 52 attributes are coded. These relate to road characteristics that influence either collision likelihood or collision severity. I won't go through that list on the screen now, but a brief impression of what we code is there. So stuff at the roadside, what kind of object is it, how far away is it from the running lane, what's in the middle of the road, what kind of junctions are there, what kind of facilities are there for walking and cycling, and so on and so forth. What's also really important, of course, is our attributes that relate to the use of the road. So that's our pedestrian and cycle flows, our vehicle flows, our mean speeds, posted speed limits and 85th percentile speeds. We actually get our 85th percentile and mean speeds from connected vehicle data and have been doing that for quite a while now, which gives us a really rich picture of how the road is being operated. What we don't have in there at the moment is anything that relates to flooding, because we don't do many surveys. We just do that one drive through in good weather so we can see on the videos what's going on the road. So we don't detect, if you like, pools of standing water or whatever. So that's one of the limitations to the system, but we're looking at ways that we can bring in connected vehicle data to inform that, so that we can make sure that we can adequately represent surface friction in our models going forward. We can also code from road design. So here you can import a road design into a GIS system, which then overlays into the GIS system, and it allows you to take measurements from the road design itself and use that as your coding information for the iRAP process. There's a lovely star rating for designs, a web application that helps support this. And as I mentioned, we're increasingly trying to use pre-existing data sources or connected vehicle data, as we do in the UK, but also there's a lot of auto-coding development that's going on as well. And there are some companies across the world that have managed to auto-code 30 of the 50 attributes from video imagery, which is terrific. Actually, from LiDAR data, I should say, which is amazing. Our coding teams that we work really closely with are starting to use AI to auto-suggest what the codes ought to be, but we're still at that stage where the coding team is supervising the AI and making sure that it's getting it right. So it's just a suggestion at this point, but advancements are coming along all the time to help make that collection of quite a lot of data a lot more seamless. What then happens is that the core coding file, which is created in a very consistent manner, is uploaded into the VIDA iRAP processing tools. and out pops the star ratings. And star ratings look like this. They're deliberately designed to be really simple to understand. Anybody can understand the difference between a 1-star and a 5-star hotel, and in which case it sort of translates to the road as well. So you can see the star ratings range from 1-star in black up to 5-star in green. I've put the raw maps on here for some of the Safer Roads Fund schemes, only so that you can see the granularity. We've got a star rating for every 100 metres along the road. We can also smooth those as well so they look nicer, but you lose some of the intelligence from those if you do smooth them. Underpinning the 1 to 5 stars are star rating scores, and these star rating scores are created for each of the road user types that I mentioned earlier: vehicle occupants, motorcyclists, pedestrians and cyclists, and each of those have different collision types within them. So the one that you can see again here is for vehicle occupants, and it provides a really detailed breakdown of the risk that's present along the route. The model takes that risk and multiplies it out by flow and estimates where fatal and serious injuries are likely to occur in the future. Each survey is calibrated using basic historical data to make sure that the total estimated fatal and serious injuries reflect the involvement of different user groups in fatal and serious injuries in the past. We also give the model quite a lot of information in that calibration process. So it's not going out there cold, just randomly coming up with numbers. You're telling it the overall number of fatal and serious injuries that it's got in its pool for that particular survey. You're also telling it the proportions for each of the user groups, and you're also then telling it the proportions for each of the crash types within those user groups. And then what it's doing is allocating those fatal and serious injuries across the network according to exposure, flow, and the inherent severity. So you're training the model quite a lot. And what comes out of that is a fatal and serious injury estimation. You can see on the map here that you've got darker sections where we expect there to be a higher concentration of death and serious injury in the future, and lighter ones where we expect those numbers to be lower. And on the right-hand side, you can see our fatal and serious injury profile. And you have those for each of the user groups, and each of the user groups have the different crash types. And that then tells us slightly different information to the star ratings. The star ratings tell us about an individual road user, whereas this tells us about the collective risk. So we've brought in flow and exposure into the mix here. What the model then does is trigger countermeasures. There are 90 countermeasures or more now in the iRAP system, and every 100 metres the model will be going through considering what sort of treatment might be effective against the sort of fatal and serious injuries that are likely to be present in the future at a given location. And it's going through, cycling through all those 90 countermeasures, working out, is that likely to be effective? What kind of impact's that going to be? Which is the best one? If I've got several options, which one's likely to have the best benefit cost ratio? And what it then does is stick that into a Safer Roads investment plan, which looks a little bit like this. So this is a series of treatments. The length to which they might be worth applying, the number of fatal and serious injuries that are expected to be prevented through application of that treatment, present value of the safety benefit, estimated cost, and a programme BCR. So taking the present value of the safety benefit and dividing it by the cost, and you get a BCR out. This gives you a rough shape of the investment that might be warranted on a route. Of course, there are all kinds of constraints and unknowns that mean that the model doesn't always get it absolutely bang on. So you might not have enough money, for example, to do all of this, or you might find that the model is suggesting to do things that you just don't have the space for. You can't purchase that land, or whatever the issue might be. So what we then do is provide you with an opportunity to refine that going forward. Now, before I show you that, I'm going to hop on to the star rating demonstrator,